Try to imagine you are standing in a pitch-black room. You light a small candle. That faint light helps you see your hands, see the wooden table in front of you. You think, is this all there is to the room? No, you are very wrong. In the darkness beyond, where the candlelight cannot reach, thousands of other eyes are staring at you. There are giant elephants moving quietly without making a sound. The room is billions of times more cramped than you imagined. Our universe is exactly like that. Every sparkling star, every brilliant galaxy, every planet, and even your own body, all that we see, touch, and feel is just the light of that tiny candle. Science calls this ordinary matter, and believe it or not, it accounts for less than 5% of this universe. So, what is the remaining 95%? Where is it hiding? Why does it determine the fate of this entire universe? Welcome to the journey of exploring the greatest mystery in human history, the world of dark matter and dark energy. Fasten your seatbelt, because what you are about to hear next may completely change the way you look up at the night sky. The story begins in the 1930s. Let's go back in time to that period. There was a Swiss astronomer named Fritz Zwicky. He was a genius, but his personality was extremely unpleasant. Zwicky was observing a giant galaxy cluster called Coma. He was doing something that seemed simple, calculating the speed at which these galaxies were moving. According to Newton's law of universal gravitation, gravity is created by mass. The more matter there is, the stronger the gravitational pull. The galaxies in the Coma Cluster were moving at an extremely fast speed, terrifyingly fast. Zwicky began counting the number of stars he could see to estimate the mass of the entire galaxy cluster. And then he was stunned. The calculation results showed that the mass of the visible stars was too little. It was so little that it could not create enough gravitational force to hold these galaxies together. At such a high speed, the galaxies should have been flung apart, scattered across the universe like runaway race cars with no brakes. But no, they remained tightly bound together. Zwicky realized that there had to be something invisible, a mysterious cosmic glue, creating additional gravity to hold them together. He called it Dunkel Materie, which in German means dark matter. But sadly, at that time, no one believed him. People thought he was crazy. It took nearly 40 years before this mystery was brought to light once again, thanks to a great woman named Vera Rubin. In the 1970s, Vera Rubin observed the Andromeda Galaxy, our closest neighbor. Let's imagine it this way to make it easier to understand. Think about the solar system. Planets close to the Sun, like Mercury, orbit very quickly, while planets far away, like Neptune, orbit much more slowly, right? Gravity weakens with distance. We assumed that galaxies worked exactly the same way. Stars near the dense center of a galaxy should orbit quickly, while stars at the sparse edges should orbit more slowly. But Vera Rubin discovered something shocking. The stars at the edges of the galaxy were moving just as fast as those at the center. Their speed was about over 200 kilometers per second. According to theory, at that speed, the stars at the edges should have been flung out of the galaxy long ago, but they were still there, orbiting steadily. This can only be explained by one reason. The galaxy is much heavier than we thought. There must be a huge amount of invisible matter enveloping the entire galaxy, creating the gravitational force to keep these rebellious stars in place. At this point, the scientific community finally bowed to admit dark matter is real. So what exactly is dark matter? This is where things get headache-inducing. When we say it is dark, it doesn't mean it is black like your shadow. Black is actually something we can see when it absorbs light. But dark matter is not like that. It is completely invisible. It does not emit light. It does not reflect light. And worse, it does not block light. Light passes through it as if through nothingness. You cannot see it, cannot touch it. Right now, billions of dark matter particles may be passing through your body, through your phone screen, through the Earth itself, without colliding with any atoms. It's like real ghosts. The only way we know it exists is through gravity. It has mass, so it bends space. Modern telescopes like Hubble or James Webb have captured strange images where light from distant galaxies is bent into circles, as if passing through a giant invisible lens. That is the fingerprint of dark matter. It accounts for about 27% of the total energy and matter in the universe. If you think dark matter is the strangest thing, just wait. The real horror story is just beginning. In the late 1990s, scientists discovered another shock, even bigger than dark matter. Since the Big Bang, our universe has been continuously expanding. Like when you throw a ball into the air, it will rise but slow down due to Earth's gravity, right? Scientists also believed that the gravity of all the stars and dark matter would pull everything together, slowing down the expansion of the universe. They began measuring distant supernova explosions to verify this, but the results shocked everyone. The universe was not slowing down its expansion. On the contrary, it was expanding faster and faster. The expansion rate was increasing every second, every minute. Galaxies were moving away from each other at a dizzying speed. This was so absurd, it was crazy. Like throwing a ball into the air, and instead of falling down, the ball keeps soaring higher and higher at an ever-increasing speed as if it had rockets attached. There must be some energy pushing the universe apart, a force opposing gravity. They named it dark energy. Dark energy is not matter. It is a property of space itself. It arises from the vacuum. The more space expands, the more dark energy appears, and it pushes the universe to expand even faster. An endless loop. Now let's look at the pie chart of the universe. This is the bare truth about where we live. 5% is ordinary matter. That means me, you, the dog, the cat, the tree, the sun, the stars. Everything you have ever known. Only a mere 5%. 27% is dark matter, the invisible glue that holds galaxies from falling apart. And the remaining 68%, the largest portion, the true ruler, is dark energy. We live in a universe where 95% of its components are things we cannot see, do not fully understand, and cannot control. Humanity, with all its pride in science and technology, is essentially just playing on a tiny island, surrounded by an endless black ocean of mysteries. Try to imagine that the structure of the universe is not made up of separate points of light, but a gigantic network, like a 3D spider web. Scientists call this the cosmic web. In this model, dark matter acts as the spider silk threads. They stretch throughout the universe, forming the backbone. Ordinary matter, that is, gases and cosmic dust, flows along these dark matter threads and gathers at the intersections. At these junctions, the density of matter becomes large enough for stars to ignite and galaxies to form. Without dark matter, the universe would not have the structure it has today. There would be no galaxies, no sun, no Earth, and of course, no you and me. We owe our existence to an invisible ghost. It is dark matter that held atoms together to create life. So how do we catch this ghost? Scientists refuse to give up. They have built giant traps, but not in the sky, rather deep underground. In places like old gold mines in the US or beneath the Gran Sasso Mountain in Italy, scientists place containers filled with special liquids, such as liquid xenon, buried kilometers deep underground. Why go underground? To avoid interference from ordinary cosmic rays. They sit there, waiting in absolute silence, hoping that among the billions upon billions of dark matter particles passing through, one clumsy particle will accidentally collide with a xenon atomic nucleus and emit a tiny flash of light. Just that one tiny flash, and the history of physics will turn a new page. Decades have passed, millions of dollars poured in, but these traps remain empty. The ghost still skillfully eludes us. Sometimes the silence of the universe is the most terrifying answer. The existence of dark energy leads to a rather bleak future scenario for our universe. Because dark energy is winning the tug-of-war against gravity, the universe will expand forever. Over the next billions of years, galaxies will be pushed so far apart that we will no longer see them. The night sky will become empty and lonely. Future civilizations, if they exist, will look up at the sky and think that their galaxy is the only one in the universe. They will never know about the existence of the Big Bang or neighboring galaxies. All traces of the universe's history will be erased by darkness. There is even a scarier hypothesis called the Big Rip. If dark energy becomes too strong, it will not only push galaxies apart, but it will tear galaxies apart, tear solar systems apart, tear planets apart, and eventually rip apart every atom in your body. The universe will end in complete disintegration, but don't feel pessimistic because of that. Discovering that we only know 5% of the truth is not a failure, but a great invitation. Look back at the glass of water on your table. Look at your hand. We are made from the dust of stars, but we live in a mysterious sea of dark matter and dark energy. Our ignorance is the driving force for science to advance. Whenever you feel small or troubled, remember this. You are part of the rare and brilliant 5%, capable of thinking and feeling about this universe. The 95% out there may be invisible, but it is our curiosity that is the strongest light to illuminate the darkness. Thank you for accompanying me on this journey into the darkness. If you found this video interesting, don't forget to hit the like button and subscribe to the channel so we can continue exploring the mysteries out there. What do you think dark matter is? Please leave a comment below. For now, goodbye, and see you again.